a series of experiments and stage show things that we will be showing to you, sharing with you, which are related to optics and properties of light, and we'll also discover how they are these small things which seem insignificant slowly actually contribute to the development of modern telescopes. Some things, of course, I have already covered in the talk in the morning because the audience was very different, and so if they are repetitive, just enjoy them. But we have more practical things, more things that you can actually see in action, and you'll notice that it makes a difference when you actually see some things practically being done rather than just learning that okay, this is done. So it's more like listening to a story and actually seeing the event of that story. So anybody saw the match yesterday? So how much do you wish that you could be there to see it, those people in action? So similarly, it's what we have here is a stage show. We are calling it Cheers to Modern Telescopes. So cheers. Let's have our characters on stage who are slightly preparing a few extra demos for you, because we want you to see all the things possible with simple equipment that we use here, right? And so while they just they'll be here in a moment, I could actually tell you about some resources as well if you're interested in educating people about your subjects. So I work at the Ayuka Institute in Pune, which is for astrophysics, but we do have a separate science center there, and it's not as big as the science center here. It is more of an activity center. So we are visited by hundreds of children, actually thousands of children every year, and with them and my team here, we perform a lot of workshops, activities, hands-on fun stuff. And all these things are done with the raw materials, the ingredients found in our daily life, or at least to be found in the same city. So we don't have to go find silicon wafers from Silicon Valley to do some special experiment or something. So all these things are from your daily life. We use things children play with all the time: paper, rubber, balloons, cardboard. Nowadays CDs are also just lying around as they have become waste. Things like those are used, and we make what we would like to call experiments, but children call them toys, and they have fun learning from these science toys. And our activity was actually jump started by a gentleman called Arvind Gupta. You have heard of his name. If you have not heard of his name, then he is a Padma Shri awardee from last year, and he is an educationist who doesn't have an education degree. He has learned through his 40 years of experience that what are the things children enjoy while learning, and all that he learned, he has collected in books, in videos, and on his online YouTube channel as well. So I've been lucky to work with him for more than 10 years, and our team, which included him and me and some other colleagues, we have contributed to this website and YouTube channel that is there online, Arvind Gupta Toys. Just look that up on Google and you'll find both. And it's a lovely resource which you can either use or pass on to people. Arvind Gupta Toys. There's a YouTube channel with more than 2,000 films up there, and a similar number of science toys have been documented, including the ways to make it and the use of them in education. So as a continuation of that team, now we have brought to you here on this stage today two people. One of them, she is Shivani Pethe, but she would like to be known today as Optics Girl. And we also have Rupesh here. Rupesh, can you come out for an introduction? Okay, so Rupesh will be here, and he would like to be called the Telescope Boy today. Okay, and together, and I will be actually looking at the show from the perspective of an old man called Galileo. So, and I'll be commenting once in a while about how Galileo would have, what Galileo would have thought of if he had seen these experiments happening, right? So otherwise, this is usually a stage show with Galileo, somebody dressed up as Galileo on stage, but we're not doing that today. So let's get on with it. And I think Shivani and Rupesh have both actually included several more experiments than what we usually have. So we'll take a lot of time.
Did it start? Yes. Okay, so hello everyone. I know you all had lunch and maybe in AC you're sleepy. I'll try to make it as interesting as possible. Okay, can we switch off the lights? Not to make you sleep, but to show you some interesting stuff. All the lights. Yes, I'll make them switch off everything. All the lights, everything, pitch dark. Okay. Thank you. So, can everyone see a laser beam? Yes. These are mostly used to do sky watching at night. So you can even see the beam going, and a spot on the wall. Can everyone see? Can everyone see the path of the beam?
It's more apparent when it's perpendicular. Can you see the beam? It's perfectly the reaction expected.
That is what we yeah, that is what we expect. Okay. दिख गया? Okay, जिनको नहीं दिखा उनको अभी अच्छे से दिखेगा. So magic powder we brought all the way from Pune. No, that's just Johnson baby powder. But yes, so can anyone tell why the beam, this is more brighter than the more particles. Yes, so exactly. Yes, so we can see the beam. Yeah, no lights. It's okay if someone wants to sleep. So yes, this is a light beam traveling in a straight line. Yes. So is this the only light beam that can travel in a straight line? Laser? Yes. Light general travels in a straight line. Yes. And if I do this, now you can see a point, right? What if I start rotating this with some speed? You can still see a point? Still a point? Now? Why? Yes. So, persistence of vision. Yes. Is it 1/10th or 1/30th? 1/16th? Oh, I get another number in this audience. Okay. So, every audience I go, there's one number extra in the persistence of vision. Sorry?
We will take average.
We'll take average. Okay, fine. So, I just want to mention that just one laser, if you have with you, this is a laser which costs much, but if you get a laser like 60 rupees, 70 rupees in any fair you go, I can have some lights now. So then just one laser you can go and tell that light travels in a straight line, and then you can explain how persistence of vision works to the kids, right? Any one of you here loves to do outreach or goes and does some stuff in some schools? And can I have some light, please? Anyone? Some interest in some outreach, or does some outreach, or loves kids? Yes, okay. So loves kids. So these are some, now what we are going to show you are some fun toys or fun activities that we do to make science interesting, or make basically physics interesting, so that just a laser pointer can be used to show that light travels in a straight line and to show how persistence of vision works. That's pretty simple, right? Yes. Have you all heard about the TMT thing? Yes. So did you get something about it in the morning talk maybe? Yes. Did you wonder how could they make such big mirror?
You know how.
Okay.
So the thing is, I was thinking about it. If Galileo was here and suddenly came to this exhibition somehow, I think he would not just wonder about how they make this telescope, etc. First thing he would start is, what is this meter? Right?
Yes.
She said 30 meter, but in his days,
Yeah.
people didn't use meters. Nice tidbit. We don't realize that things evolve, science evolves, even units evolve, and they would use inches and feet at that time. So Galileo would call his telescope a 2-inch telescope rather than whatever 5 centimeter telescope or something. So
Yes. So that time they use inches, but now if he comes here and if you wonder, it's a 1200 inches big thing that we are making. Yes. So for him, 1200 inches big. First he would have thought that how could you make such a big lens? Because he didn't know that we could use mirrors to make telescopes, right? That is what.
I mean, Newton, who made the first kind of working reflecting telescope, was born in the year Galileo died. So nice trivia. So Galileo never knew that there are reflecting telescopes in the making in the future.
So apart from the fact that the lenses could have become very huge, they are very heavy, they are very difficult to handle. There must be something a little bit scientific also to discard lenses and make mirrors appear in the telescopes, right? क्योंकि बहुत heavy है, नहीं कर पाएंगे, ये तो हम overcome कर लेते. If that would have been that much required, but नहीं किया. तो have you ever thought कि lenses को नहीं लिया? And he thought about mirrors.
It will absorb light.
So let's see what lenses do first, and then we'll come to why mirrors and why not lenses. Okay? Let's see what lenses do first. Can we have the lights off? Off. Can you see a light beam inside water? Another? Can you see 2 of them? Now, yes?
The worst, huh?
Now I'm putting in something which will change.
ठीक है ठीक है
Okay, this is one. Can you see what is happening before the lens and what is happening after the lens? Or what is happening to the ray before and where is it going after? Can you see the effect of the lens? The people sitting in the front can maybe see, and if we can do this, maybe you can see. Can you see?
सर इटली कर सकते हैं
नहीं थे बैटरी सही मुझे
लेकिन
Blue one.
नहीं क्लियर
Okay.
नहीं दिख सकती
maybe we can see 2. Can you? Okay.
Can't see.
Now if you can see 2 fainter ones but 2. Yes? What is happening to the rays before the lens and what is happening to the rays after? बीच में Can you spot the 2 okay, spot the 2 points on this side of the tub and that side of the tub. Are they like equally spaced? What is happening to them? The points are coming closer? Yes. We have the second lens. Let's see what happens to the points. Now they are like same distance. And now? यहाँ के 2 देखो, वहाँ के 2 देखो. Are they pretty much away? Yes. Okay, thank you. Can we have the lights on? Okay. So, which was the first type of lens? You should have guessed. Yes. And which was the second type of lens? Concave. Yes. So, this is a pretty good like experiment or toy you can show to the kids, because mirrors में क्या होता है? Convex, concave. Convex. In mirrors it is opposite. So in schools when you write papers you don't realize कि ये mirror है या lens है, and then you get confused, like the kids get confused. And so what we can do is